this told us, if we look at the directions here for g of x, okay, here's f and here's g. G says I'm going to triple all of my output, all y values, which translates into a vertical stretch by a factor of 3. That's the language we use. This is the actual action that you do to all your y values. So notice here, A was at 5. It's going to be tripled. It's going up 3 times its height. Same with all these points. That's the one that's intuitive. 3 is outside the function or post-operation. F tells you what you're going to do to every input. Once you do that to every input, you get an output, and then that output is being multiplied by 3, so that's vertical. Anything that's post-operation is vertical. So all my y values are going to be tripled. It's times 3. It's intuitive. It's what you expect. Once you move inside to the input, life changes. The input says, I have to change my input values. All my input values now to be at the same distance above the x-axis only have to be half the size because I'm doubling all my input. So to be back to where I originally was, I only have to take my x value that's half of the original size. So one way to think about this is, what do you have to do to 2x, which is inside your function, to make it back to x? What would I have to do to double? If I'm doubling x, how do I inverse that and get back to the original x? If I double x, what would I do to it to get back to x? Divide by 2. So this tells me to divide all my x values by 2. It's not intuitive. Divide all my x values by 2, which is exactly the same as multiplying all my x values by a fraction, which is the reciprocal of 2. That fraction is 1/2 by 1/2. So the way we talk about this shape change is we say that it's a pre-operation. Before you even perform your function, you're working on your input. Input is domain, it's horizontal. So this is a horizontal. And since your x values are being cut in half, it's a horizontal shrink by a factor of 1/2. Anytime you use the word shrink and you're using the word factor, the number that comes after factor has to be a fraction to shrink it. You could also say this is a horizontal shrink by dividing all my x values by 2. I don't care if you literally tell me what you do to all the x values and you put it with the phrase horizontal shrink, or you use the word factor by 1/2. I don't care which way you tell me. Whatever makes the most sense to you is fine with me. So that's what your points look like, and I think everybody got it from looking around. You went through this little chart here. Let's take a look at our 2 domains. The domain for G, and we want to compare it to the domain of F. We compare here with division. So the domain for G, it goes from -3 to 2. The domain for G is 5 units wide. And the domain for F goes from -6 to 4. That's 10 units wide. So that has this ratio, 1 to 2. So the domain of G is half the size as the domain of F. The domain of G is half the length. You could say half the length or half the size. Half the length would probably be better. Half the length of the domain of F. because you shrunk all your x values. So that should be reflected when you look at the length of your domain. You can see this domain only stretches from -3 to 2, which is half the distance from -6 to 4. Now all your output were tripled. So you should be expecting the range of G. When you compare the range of G to the range of F, it should reduce to what number? 3 to 1. Yes. The range of G goes from what? From 3 all the way up to 21. So the range of G goes from 3 to 21. The range of F goes from what to what? 1 to 7. So the height of this range is 18 units. That's the distance between 3 and 21. And the height of this range goes from 1 to 7, so that distance is 6 units. So 18 is to 6 as 3 is to 1. That's your coefficient. That's post-operation outside of all of the f of x. Okay, so that's how you can check to make sure. And you could always go back and put these different values in for everything here. Put the -3 in, you double it, you'd come back to -6, you'd get your output. Okay, you don't have an equation here for f, so all you know is that when x is -6, your output is 5. That's all you know about this function. You don't have the formula for it. So if you were checking yourself, a lot of you are going in and placing a value for x in here, versus saying, okay, what must my x be for me to be a -6? Because all I know right now, all I can tell you that is that if x is a -6, my output is 5. So you look in here and you say, my 2x, in order for me to get any information about this function, when I throw it into my function machine, here's my function machine f. The only thing I know about f is I know the answer for the output when the input is -6. I know the answer when my input is -2. I know the answer when my input is 0. I know the answer when my input is 2. And I know the answer when my input is 4. I have the answers. I know what the output is. Now what's going into f is 2x. So I say to myself, geez, 2x has to be a -6. Because I know when I put a -6 into my f machine, out pops the number 5. So if 2x has to be -6, then I divide both sides by 2. And that tells me if I now put -3 into this new function machine, it's going to be giving me a positive 5. Then once I get my 5, I triple it and get 15. Okay. So the only information you know about this function is these 5 points, the information on these 5 points. That's all you know. You don't have a formula to plug it into. So if x is -3, and you put a -3 in here, 2 times -3 is -6. You can say, oh, if I put -6 into f, I know what my answer is. It's 5. But to get a -6, once you've doubled x, x has to be half the size. That's what's going on. It's a lot harder to say. It's a lot harder to think about and put this all together, but it will come with practice. Okay, so let's do a little demo now and take a look at our summary. Does anybody actually have their book with them? If you do, open it up to page 280 for your table, and I'll go into my math lab and, oh, I don't want that, cancel, and open it up. Actually, I'll just wait for someone to, no, I'll show it. Let's go into my math lab. It's worth seeing because there's a change in how we we've chosen to write multiple transformations compared to your book. I hope I did that right without. Did I spell my name right? Nope. 2 G's. All right. All right, let's get our textbook out. Multimedia library. And what chapter? We want chapter 2. We want transformation of functions. So find that right now, please. Is it finding it? There. Oh, right here? No, didn't find it. Oh, I didn't tell it what to find. Multimedia textbook, thank you. And here's a section, and I want page 280, and I think it's going to open up on 279. Let's see. Actually, I don't have to record all of this. Okay, so your book, notice your book, when you look inside at the input, it's always going to be, every problem you see in your book is going to be x minus something, x plus something. It will never be in factored form. See, this is just an adding or subtracting problem inside there. That's what example 8 looks like. And if you look at, and it tells you how you transform it, it goes through all the movements. And if you look at the next page, notice again, it's x plus 1, no multiplication. Notice this, x plus 1, no multiplication. So they do not have, in all of the problems they give you in the text, only has inside the parentheses x plus a number or x minus a number. They do not have any multiple, any factor in them multiplying x plus 2 or x plus 1, whatever they have. Down here they do, but notice there's not a plus or a minus here. Well, that's not that realistic based on where you're all going. When you go to Math 108 or Math 151, you're going to see a formula like we're going to look at in a minute. So you need to totally disregard this order when you have multiple transformations. They're telling you this based on this format, not the format we're looking at. So you need to cross that out and not pay attention to it. What you need to do is to see that every single transformation that we're going to look at in this class, this is a multiple transformation. It has all your horizontal shifts up and down in this, reflected in this. It has all of your vertical shifts up and down reflected in this, and it has your vertical shrinks and stretches as well as your horizontal shrinks and stretches by just looking at this formula. Now, it's a little intimidating when you first look at it, but what I want you to do is see the difference between what's inside the parentheses, your input, compared to what your book did. You see how this doesn't just say x plus c, it has b times the quantity x plus c? It's factored. This is in factored form. And whenever your input is in factored form like this, you'll always do your shape changes first. That's what's in this big box here. You'll always do your shape changes first, both your vertical shape changes and your horizontal. Then you just do your movement, right and left, up and down. All right? So that's the big difference. Ignore the book's directions on the top of page 280. We have it right here. This will better prepare you for pre-calc and applied calc. No, reflecting is fine. Reflecting will come in with this thing right here. A and B will be either positive or negative. So you'll be doing that anyway. Yes. Okay, so let's look at these letters and see which they do. So which one of these constants is going to move this function? C and D. Do we have agreement with that? Okay, D, notice is if I made this expression into two terms, remember terms are where you have adding and subtracting. If I put a box around here and a box around here, D is a term that's been added or subtracted, depending on whether D is a positive number or a negative, to the entire output. Here's your entire output right here, this first box. That's your Y value. And then you're either going to move it up or down. Horizontal happens inside, right? Pre-operation. Here's my operation, F, that's my function. I'm inside my innermost parentheses. C is going to tell me if I move it right or left, depending on whether it's a positive C or a negative C. Now, someone else other than Fabian, since he answered A, which of the constants change the shape of the function? A, because it's on multiplying the output. A is multiplying the output. It's multiplying your Y values. Definitely A. And someone other than Amber for the other thing that B. Yep, Dean, that's correct. All right. All right, so now we know which ones move it and which ones change its shape. Now we want to see which of these constants affect the graph horizontally by either moving it or changing its shape. So which constants change the graph horizontally? C, yes. And someone, Melanie or Clay? D, that's a vertical because it's post-operation, so it's not going to change it horizontally. It's way outside of everything that's been calculated. A changes it vertically because it's outside the function. So we have to go inside our input. For horizontal, it's domain. So it's B, the only one left, right? B. Okay, which of the constants affect the graph vertically? Well, we've already used C and D, so what are we left with? Excuse me, we've used C and B. Notice those are in the parentheses after our function. So what's left for vertically is anything outside of our function, which is D and A. D and A. Now, this whole thing about comparing the effects of the constants, that's what we've been working with on class 10 and 15. We know that if you're a vertical change, A and D, it affects it exactly as you see it. If you're tripling something, the Y values triple. If you're taking half of the Y values, there's a half out here, you take half of the Y values. If there's a plus D, it moves up. If it's minus D, it moves down. It works just like you think it does. However, the horizontal effects are inverse of what you think. So if you see a plus 2 here, instead of going to the right 2, you go left 2. It's the inverse operation. If you're doubling something, you're dividing by 2 or multiplying by a half. It's exactly the opposite of what you think. So the effects are different. So here's your class activity. Now here's all of the possible things you could be doing to the function f. Notice you're not going to fill in all the blanks. If the sentence doesn't apply, put NA. So if something doesn't apply, put in NA. And once you've finished 1 and 2, please have me check and I will come around. And then if you haven't finished 16, please go back and finish it before moving on to 17. By the time you walk in here Wednesday, you need to have 15, 16, and 17 completed to take your quiz on Wednesday. Okay, what time do you have to be here if you want to take the group quiz on Wednesday? By 10:45. If you walk in at 10:46, you're on your own. Okay, how big is the group? As many as you want.